friends, welcome to A1 Education, in which you can enjoy your learning. Today in our class, we are going to learn 8th class physics, the first lesson, force, the third part. In before video, we have learnt the two parts of this lesson. This is the last part and the remaining part of this lesson. Okay, before going to the lesson, friends, if you like this video, please like and share and subscribe for more lessons. Okay, going to the lesson. To explain this remaining part, we are going to take an activity. In this activity, we need a table and a brick placed on it. That's all. This brick has simultaneously facing two forces on this plane surface table. In real life, many forces act on an object simultaneously. Like that, this brick is also facing two forces. The two forces are gravitational force and the normal force. Gravitational force and this normal force. This gravitational force and the normal force are explained in the before video. If you missed this video, please see that video. Okay, this gravitational force and normal force. This gravitational force and the normal force are opposite in direction and they have equal magnitude. Magnitude means it is also called as strength of the force. So these are in opposite direction and in equal of magnitude. So they cancels. And here the net force acting on this brick is 0. 0. So here what is 0? The net force is 0. The net force is 0. What is net force? To define this net force, I will tell a sentence. A net force is a force that replaces the original forces. Here, the direction of the net force is the direction of the motion. Understand? The direction of the net force is the direction of the motion. What is motion? When there is two forces acting on an object, the greater force acts on an object makes the object to motion. So this is called motion. This net force makes the direction of the motion. Okay, you understand this motion of this net force. In this net force, this object is in rest now. But if in a motion, how to calculate this net force? Now keep the same object in a lift which is accelerating. What is accelerating? Non-uniform motion. Non-uniform motion. Uniform motion means if you started at a point at a particular time at 0 kilometers, after a 1 hour you are at 5 kilometers away from the starting point, and after another hour you are 10 kilometers away from the starting point. So here you are in a uniform motion. You are in a uniform motion from the starting point to the 10 kilometers. What is that uniform motion? 5 kilometers per hour. This is uniform motion. What is non-uniform motion? You started at a point at 0 kilometers. After 1 hour, you are at 6 kilometers. And after 1 hour, you are at 18 kilometers. Here, your speed continues in non-uniform motion. So, this is called non-uniform motion. Non-uniform motion is also called as acceleration. Acceleration. So you keep this brick in an accelerating lift. Now this brick in rest or motion. It is at rest respect to the lift and it is in motion respect to the observer who is observing. So technically this brick is in non-uniform motion and it is in motion. So how to calculate this net force? How many forces are acting on it, on this brick? 3 forces. Gravitational force, normal force and accelerating force. Now this brick has the net force 0. Can anybody think? Does this brick has the net force 0? No, because this gravitational force and normal force are in equal magnitude and in equal distance or in opposite distance. But this acceleration continues in a non-uniform motion. So it is not 0. It is not 0. So always the net force won't be 0. It changes particularly depending upon the forces acting on it. Next one is calculating the net force. Calculating the net force. To calculate the net force, you should take a free body diagram. Free body diagram means the diagram which has all the forces at a particular instant. Means which has all forces at a particular instant. Now we draw a free body diagram. For example, take a car. Take a car. This is at a particular instant when it is moving. How many forces act on it? Many forces act on it. This is friction. Small f is denoted friction. Denote friction. And big F denotes the applied force. Two forces of the opposite direction. And now to the downwards direction, the gravitational force acts, and to the upward direction, the friction normal force acts. And 1 and 2. These all forces act on this car. This is called free body diagram. At an instant, all the forces acting on it is called free body diagram. Now calculate these net forces on this free body diagram. How to calculate? To calculate, we should take a coordinate system. Coordinate system. What is coordinate system? Which contains x and y axis. The sign conversion also be used. Now calculate the forces acting on the x axis. X axis. Acting on the x axis is F minus F. On this x axis. And the second y axis. Y axis means N1 plus N2 minus gravitational force. This acts on this y axis and this acts on this x axis. Like this, you should calculate the net force. The net force has a unit in SI system. What it is? Newton, and denoted by N. Okay, you understand this net force? We are going to the next part, other effects of force. Other effects of force. What is other effects of force? The force can act in other effects. The first effect is it can change the shape of the object temporarily or permanently. Temporarily or permanently. What is temporary and what is permanent? We have discussed in our first video that we will compress a sponge for a few seconds till the force is acting on it. After we release it, it will come back to the square shape. So this is the temporary change of the sponge or an object till the force is acting on it. What is permanent? Take a paper and tear it. Our hand applies a force on it and tears it into pieces and pieces. Now you can stitch it? No. So this is the permanent change. This is the temporary and this is permanent. So the force can change a shape of an object temporarily or permanently. This is the first effect of force. And the second effect is, this is very important one, pressure. Pressure. What is pressure? Take a pen and ping it to your hand. Poke it to your hand inwardly. Means nip to your hand. What will happen? You will get a pain. and invert it, means nib up and the down part to your hand. It somewhat nothing pains due to the so it doesn't pain. This effect is due to the pressure. Pressure means if there is area of contact less to an object, the pressure will be more. If the area of contact is more to the object, the pressure will be less. This is also an effect of force. It acts with the effect of force. For example, the lorry loads will carry very heavy loads like tons of weight one, tons of weight. But why it carries in a stable? Because the tires will be very broad to it. So this is area of contact is very more. So the pressure will be less on the road. So it runs smoothly. Our bags, school bags. The school bags will be have a broad stiffs. Why? Because to don't overload on our shoulders. So this is also a effect of pressure. But when there is area of contact is very less, the pressure will be more. When sewing, the needle will be very thin. So the pressure will be very more. So it deflects to into the cloth. So this is pressure. Pressure has a unit. What is unit? That unit is Newton per meter square. Why this is meter square? Because this is about the area. Area means you can take in it meters. The force acts on the object on this area of contact. So we take this meter square. So this meter into meter square. Why this m square is meter square is done? Meter into meter square, length into breadth. So meter square. Pressure formula. Pressure contains a formula. What is that formula? F by A. Force by area denotes the pressure. For example, pressure is equals to force means force. I told you na newtons. Force is denoted by newtons. So 18 newtons. Think it is 18 newtons and area some 2 meters. 8 newtons, 2 meters area. 8 newtons, 2 meters square. 2 meters square. 8 into 2, 16 Newton per meters. So, this is not 16, this is 4. 8 by 2, 4. 4 Newton per meter square. This is the pressure formula. The pressure is also an effect of force and it depends upon the area of contact. So today we have completed this lesson. Oh, thank you for supporting me, friend, and if you like this video, please like, share and subscribe. Okay, in our next video I will come with a new lesson with a new subject. Thank you.